Today let us solve miscellaneous exercise of chapter 9 straight lines from grade 11. The first question is find the value of k for which the line k minus 3x minus 4 minus k square y plus k square minus 7k plus 6 is equal to 0 is parallel to the x-axis, parallel to the y-axis, passing through the origin. So the given equation is, so in this the first question says that you have to find the value of k, okay, where this line is parallel to x-axis. So when you say the line, imagine the line ax plus, by plus c is equal to 0. If it is parallel to x-axis means this particular part means the x term should be equal to 0. That means what? A should be equal to 0. That means here coefficient of x is a, correct? That means k minus 3 is equal to 0. So k is equals to 3. That's for the first question. Okay, if you move to the second question, in the second question what they're saying, so here the line parallel to y axis. So same concept, if you use the line is parallel to y axis means if I take an equation ax plus by plus c is equal to 0, the y term should be equal to 0. That means what? B should be equal to 0. B is coefficient of y. So here coefficient of y is minus 4 minus k square. So minus of 4 minus k square is equal to 0. That means what? 4 minus k square is equal to 0. That means k square is equal to 4. So therefore what I can say? K is equal to plus or minus 2. Now let's move to the last question. The last question is what? Passing through the origin. The question C, it says that passing through origin. Okay, so origin means if any line passes through the origin like this, so coordinates of origin is 0, 0, correct? That means here x coordinate is also 0 and y coordinate is also 0. So that means what I can take? Only k square minus 7k plus 6 equal to 0. So only this is left over, right? Because x is 0 means this particular part is 0. Y is 0 means this particular part is 0. So therefore the remaining is only c. So k square minus 7k plus 6 equal to 0. So now let us split this. If you split it, it will be 6k minus k plus 6 equals to 0. That means k minus 6 into k minus 1 equal to 0. So therefore what I can say? K is equal to 6 and k is equals to 1. So that's an answer for the first question. Okay, let's move on to the second question. Find the equation of the lines which cut off intercepts on the axis whose sum and the products are 1 and minus 6. So according to the second question, there is a line which cuts the intercepts. So x and y cuts x-axis and y-axis at intercepts, right? So for this line we have an equation that is x by a plus y by b is equals to 1. So here a and b are the intercepts. So according to the question, they are saying that the sum and the product, okay, the sum of the intercept is 1. Let me take it as equation number 1 and let me alter it. Let me say therefore b is equals to 1 minus a. And then what they had told, the product of the intercept is minus 6. So it is our equation number 2. Okay, so from the equation number 1 we got b as 1 minus a. We replace here b as 1 minus a. When we do that, what do we get? A into 1 minus a is equal to minus 6. So if you open the bracket, a minus a square is equal to minus 6. So it looks like a quadratic equation. So I rearrange it in the form of quadratic equation. So that will give a square minus a minus 6 is equal to 0. So the sum should be minus 1 and the product is minus 6. So we can split this as a square minus 3a plus 2a minus 6 equal to 0. Solve it further. So we will be getting a minus 3 into a plus 2 is equal to 0. So therefore I will get two answers. A is equal to 3 and a is equal to minus 2. So we will be taking these two as the two different cases. So what happens? As we have got two different cases, let us take a as 3. When you take a as 3, b becomes 1 minus 3 because b is basically 1 minus a. 1 minus 3 is equal to minus 2. So according to the equation, x by a, x by 3 plus y by b. So b is minus 2. So take an LCM here. So 3 to the 6. So I'll take 6 other side, becomes minus 6 because 3 into minus 2 is minus 6, correct? And then minus 2 into x is minus 2x. 3 into y is 3y. So minus 2x plus 3y is equal to minus 6. Now let us remove this negative sign from here. So we get 2x minus 3y is equal to 6. So next case, when I'm taking a as minus 2, b becomes 1 minus a, right? So b is 1 minus a, right? So 1 minus minus of 2, which gives you 1 plus 2. That means b becomes 3. So now we are replacing a as minus 2 and b as 3, right? According to this equation. So what do you got? X by minus 2 plus y by 3 is equal to 1. Take LCM. 3 into x is 3x. Minus 2 into y is minus 2y. 3 into minus 2 is minus 6. Take 6 other side. It becomes minus 6. So this is your second equation. Okay. This is the second question. So let's move on to the third question. What are the points on the y-axis whose distance from the line x by 3 plus y by 4 is equals to 1 is 4 units. So as you look into the third question, it says x by 3 plus y by 4 is equals to 1. It is at a certain distance from the y-axis, okay? And they want us to find the points on the y-axis which are at a distance of 4 units. 4 units from y-axis, correct? So in case if I draw a rough diagram like this, so this is going to be the line, okay? And we need to find which all are possible points which are at 4 centimeter or 4 units away from the line. That's what we need to find. To continue with this, let us arrange this in the standard form. That is x by 3 plus y by 4 is equal to 1. Take an LCM. It will be 12 and 4x plus 3y is equals to 1. That means 4x plus 3y is equals to 12. If I rearrange, equation becomes 4x plus 3y minus 12 is equals to 0. Okay, it's going to be the first, it's going to be our equation, okay? And this line is at a distance of 4 units from the y-axis, correct? So therefore, if I take y-axis, what I can say, we need a point on the y-axis, right? So the point on y-axis, we'll take it as 0 comma y, which represents x1 comma y1, okay? And the distance d, we will take it as 4 units, which is already given. So according to this, we have a distance formula, that is d is equals to a x1 plus b y1 plus c, okay, in the modulus, divided by root of a square plus b square. So here d already given, which is 4 units. So let's go for substitution on that. So we will take d as 4 units equals to a as 4 from the equation, and x becomes 0, plus b is 3 and y we will take it as y, so 3y minus 12, okay, divided by root of a is 4 square plus 3 square. So further simplification, 4 is equals to, this becomes modulus of 3y minus 12 divided by root of 4 square is 16 and 3 square is 9. 16 plus 9, 25, correct? So this will be root 25. So root 25 is 5. Now let us take the 5 other side. Okay, if you take 5 other side, it becomes modulus of 3y minus 12 is equals to 20. So since there is a modulus, we will be getting two different answers for this, correct? That means two different cases. So let us take the first case as modulus of, let's remove the modulus now. It is 3y minus 12 is equals to 20. Okay, the next one, 3y minus 12 is equal to minus 20. As it is modulus, there are two possible values. One is positive and one is negative. So accordingly, it becomes 3y is equal to 20 plus 12. That is 3y is equals to 32. So therefore y is equal to what? 32 by 3. So in the second case, 3y is equal to minus 20 plus 12. So that is 3y is equals to, what do you get? 8 minus 8. So y is equal to minus 8 by 3. So there are two possible values, right? So therefore, according to the question, the points which are at 4 units away from the line, okay, are one is 0 comma 32 by 3 and another one is 0 comma minus 8 by 3. Okay, that's an answer for the third question. Let's work on question number 4. That is, find the perpendicular distance from the origin to the line joining the points cos theta, sin theta and cos phi, sin phi. So this, according to this question number 4, we have x and y axis, okay, and also there is one line, and on this line we have 2 points. One is cos theta, sin theta, another point is cos phi and sin phi, and this is a line which joins these 2 points. So what they are asking us to find? They are asking us to find the distance of the line from the origin, means this distance we need to find. Okay, to find this distance, we already know the formula, correct? So what's the distance formula? So in the distance formula, ax1 plus by1 plus c will give you equation of this line, and x1 y1 will be going to be this particular point. So if you take that point, so that point is origin, correct, which is going to be 0 comma 0. So this point we have to substitute. So before substituting in this equation, we basically need the equation of the line. So that means we need equation of this particular line. Okay, now according to that, these are the 2 points which is given, correct? We will take them as x1 y1 and x2 y2, so which is called as 2-point form, which is called as 2-point form. Okay, what is 2-point form? Okay, this is a formula. So this formula we are going to apply. So already we know what is x1 y1 x2 y2. Let us go for substitution of these coordinates in this equation. Okay, so substitution is done. Now we look into it. It is sin phi minus sin theta, correct, which is sin a minus sin b, and cos phi minus cos theta, it is cos a minus cos b. That means we are going to apply those two identities. Okay, so let me write those identities here for better understanding. So this is what we are going to use. So let us apply it over here. Okay, so sin phi minus sin theta. So we'll apply this. This will be y sin theta is equal to a is phi and b is theta. So let us apply exactly the same identity. So now you can see here, we can go for some cancellations. That is minus 2 and minus 2 cancelled. Sin phi minus theta got cancelled, correct? Now the remaining part will transpose the other side. So when you do that, it becomes, okay, next step, we are going to open the bracket. So if you open the bracket, y into this will give you sin phi plus theta by 2 into y. Okay, fine. So this is our a. Now then minus sin theta into sine phi plus theta by 2. Okay, so this is not required. Okay, not required. Okay, now next equals to, over here this becomes minus into x, correct? So minus into x will be minus, so this becomes minus cos phi plus theta by 2, okay, into x. Then next this into this, that is minus into minus. So now what we will do, basically we need a standard form, correct? What is the standard form? It is ax plus by plus c is equal to 0, correct? It is a standard form. The equation should be in the form of ax plus by plus c. Now you can see here we have an x term with a negative sign, here y term with a positive sign. So I'm going to transpose entire right hand side to the left hand side to arrange it in the standard form. So what happens when I do that? So what I will get, in the bracket we'll be having cos phi plus theta by 2 cos theta plus sin phi plus theta by 2 sin theta. So this is what I get. Now if you look into this, it is cos A cos B plus sin A sin B. So cos A cos B plus sin A sin B is also one of the identities, correct? So let me write that identity. Okay, so that will be, so if you focus here, now see cos A cos B sin A sin B. So A is phi plus theta by 2 and B is theta. So in case if you are solving, if you interchange also no problem. So both the answers are correct. So what I will get, so these parts I'm going to keep as it is. Okay, now this particular part we need to solve. Okay, this is an angle, right? If you solve this, what happens? 2 into theta, I will get 2 theta. So this will be theta minus 2 theta will give phi minus theta. Okay, we can arrange in that way. And if I take two other side, if I take an LCM, it becomes phi plus theta minus 2 theta by 2. So theta minus 2 theta will give you minus theta. So this becomes what? Cos of phi minus theta by 2, which is equal to 0. Now our equation is ready. Now this particular part represents A, this represents B, and this represents C. So this we are going to substitute in our distance formula, correct? So what is that? So distance, okay, D is equal to A x1 B y1 C y1, right? So x1 y1 are 0 comma 0. So what I can write is A is cos phi plus theta by 2 into 0 plus B sin phi plus theta by 2 into 0 minus C, correct? C is this, which is cos phi minus theta by 2 modulus, and denominator will be root of a square and b square, right? A square is what? Cos square phi plus theta by 2. That is cos square phi plus theta by 2 plus sin square phi plus theta by 2. So we know that it is sin square theta plus cos square theta, the first identity, which is going to be equal to 1. Okay, we are going to replace this as 1. The next step. So D is equal to, so 0 and anything is same 0, right? So these two terms are cancelled. Okay, now left over is only this particular part. That is modulus of minus cos phi minus theta by 2, okay, divided by 1. So therefore our answer is D is equal to modulus of minus cos phi minus theta by 2, okay, by 1, which is nothing but equal to 1. So that's an answer. Okay. So in the fifth question, find the equation of the line parallel to y-axis and drawn through the point of intersection of the line x minus 7y plus 5 equal to 0 and 3x plus y is equals to 0. Okay, in the fifth question, okay, what they want us to find is, see, there is x and y axis and there are two lines. Okay, just I'll draw a random line here. Say for example, it's like this, okay, just for understanding. Okay, this is the line with the equation x minus 7y plus 5, and this is another line which is, say for example, 3x plus y is equal to 0. Okay, just for understanding, it may not be according to the equation. Okay, now these two lines met at one point. Okay, this is the point P. Say for example, px comma y. We need to find equation parallel to the y-axis and drawn through the point of intersection. So we want one line which should be parallel to y-axis and passing through this particular point. Okay, that means we need equation of this line. Okay, so for that, what do we need? First we need the point coordinates of the point px comma y. So let's find that. Okay, to find that, let us solve the given equations. So given equations are, say for example, not example, it's given already, 7x minus 7y plus 5 is equal to 0. It's going to be our first equation. And second equation was, it is 3x plus y is equal to 0. So let us rearrange it. Y is equal to minus 3x. Now this is equation number 2. So what we will do, we will substitute, okay, equation 2 in equation 1. So when we do that, what do you get? Y we are replacing it by minus 3x. So this is x minus 7 into minus 3x plus 5 is equal to 0. That means x plus 21x plus 5 is equal to 0. So when you add this, you get 22x and transpose 5 other side, you get minus 5. So therefore, x is equals to what? Minus 5 by 22. So x coordinate is over. So now let us find the y coordinate. So for this, let us use equation 2. Okay. So now we are going to take a help of equation 2. In the equation 2, substitute x value. What is that actually? Y is equal to minus 3x. So minus 3 into x is minus 5 by 22. So you'll be getting what? Y is equal to 15 by 22. So the point of contact, okay, point of intersection, not contact, intersection. So P is equals to what? This is going to be minus 5 by 22, comma 15 by 22. So equation of the line passing through this point and parallel to y-axis given by x, which is equal to what? Minus 5 by 22. Okay. Now let's move on to the question number 6. What does it say? Find the equation of a line drawn perpendicular to the line x by 4 plus y by 6 is equals to 1 through the point where it meets y-axis. Okay, according to this question number 6, question number 6, the equation given is x by 4 plus y by 6 is equals to 1. Okay, and this equation touches the y-axis. That means this represents a line, correct? So if I draw a rough diagram, imagine this is the line given, okay? And if we keep in the standard form, it will be what? This will be 3x plus 2y by 12 is equals to 1 because I'm taking LCM as 12, right? So I'll multiply this by 3 and this by 2. So the equation becomes 3x plus 2y is equals to 12. Okay, now this is the equation. Now according to this, what is happening? So this gives you a line. Imagine I'm considering this as the line. Okay, so if I want to find the y-intercept, this is the y and x, correct? So if I want to find the y-intercept, I will take x as 0. So I will get here 6. Okay. If I want to find the x-intercept, I'll put y as 0. This will be 4. Correct. Now what actually they want? They want a line which is perpendicular to this particular line. Which line? That is 3x plus 2y is equal to 12. And it has to be perpendicular to this line. That means we want equation of this line, which is perpendicular to this. So for that, what actually we need? In this case, the slope of this line into slope of this line will be equal to -1, correct? So imagine the slope of this line is m1 and slope of this line is m2. So m1 we can find, correct? So slope m1 we can find. So what is m1? If you take a formula, that will be minus a by b, correct? Or else you can just rearrange the equation. So that will give you what? Minus 3 by 2 is the slope m1, which is slope of this line. Now I want slope of this line, correct? So we know that for a perpendicular line, okay, for a perpendicular lines, when you multiply the slopes, that is m1 into m2 should be equal to -1. That means m1 already we know, which is minus 3 by 2 into m2, which is equal to -1. So you can cancel minus and minus. So m2 is equals to 2 by 3. So 2 by 3 is the slope of which line? The second line which we want. Okay. So now next one, we want a perpendicular line at the point of intersection of the line and the y-axis, right? That is this. So it is 6. Already we got it, correct? So therefore, point of intersection, okay? Point of intersection of the line 3x plus 2y is equal to 12 at y-axis. Already we know what is that. It is 6. So therefore, how can I write the point? Point as 0, 6, right? So on the y-axis, x is 0. So it becomes 0, x. Now I need to frame the equation. Okay, now see, I know the slope. I know one of the point, correct? We can use slope point form, right? That already you know. What is the form? That's going to be a slope point form. Okay, what is slope point form? Okay, so that is y is equal to mx plus c we can use. This formula also we can use. So if I use this point, y is 6 and we want c value. So I'll take y as 6 and this m is going to be what? It is 2 by 3 and here x is 0. So I'll put x as 0 and c I need to find. So when I solve it further, I'll be getting c is equal to 6, correct? Now I can put in this form, okay? That is y is equal to mx plus c, correct? So we want equation, so I'll keep y as it is. Slope already we know, which is 2 by 3, x as it is plus 6. So now if I cross multiply, it will be 3y is equal to, so 3 goes here also because I'm going with the LCM. If I do the LCM, it becomes 2x plus 18 by 3. I'll take 3 other side, okay? It becomes 3y is equal to 2x plus 18. If I rearrange the equation, what do I get? 2x minus 3y plus 18 equal to 0. That means I transpose 3y this side. I got 2x minus 3y is plus 18 is equal to 0. Now this is going to be the equation of this particular line. So let's move on to question number 7. Find the area of the triangle formed by the lines y minus x is equal to 0, x plus y is equal to 0 and x minus k is equal to 0. That means there are 3 lines we can see. Okay, it's question number 7. There are 3 different lines, okay, and they intersect at points A, then point B and point C. So to find the area of this, we need to find the coordinates of these points, okay? Let us take equation of this line as y minus x is equal to 0 and equation of this line as x plus y is equal to 0, okay? So and equation of, so 2 lines over and the third line, okay, this is the third line. So we take equation of this as x minus k is equal to 0. Okay, we need to solve equation one by one. Okay, so if I want to find the coordinates of A, it is intersection. Okay, let us label these equations. Let me take this as equation 1, this as equation 2, and this as equation 3. So if I want to find this equation 3, right, line 3, okay, if I want to find coordinates of this point, it's intersection of equation 1 and equation 2. So we are going to solve, okay, equation 1 and equation 2. Okay, so as you can see here, if I take equation 1, from the equation 1, y minus x is equal to 0, correct? So x is equals to y, or you can go with the elimination method. Okay, so equation 1 plus equation 2. So if I do that, what I will get, y minus x is equal to 0, and here we can write, we will rearrange and write, that is y plus x is equal to 0. If I solve, I'll be getting what, x and x cancels, so 2y is equal to 0, so y is equal to 0. Since y is equal to 0, I can write even x is equal to 0, correct? It's understood, because y minus x is 0 and y is 0, so 0 minus x is 0 only, right? So therefore we got the point A. What is point A? X is 0 and y is 0. So let me write this as 0 comma 0. Okay, now that is the first equation, first coordinates of first point. Now let us find the second point. Okay, to get the coordinates of point B, we need to solve equation 1 and equation 3, correct? B, you see, intersection of equation 1 and equation 3. So now we are going to solve. Okay, let us solve equation 1 and 3. If I'm going to solve 1 and 3, you see, x minus k is equal to 0, right? So therefore x is equals to k. So that means what? Y I can find easily, correct? X is equals to k. It is from what? Equation 3. This I got from equation 3. Now I'll put x is equal to k in the equation 1. So from 1, it is y minus x is equal to 0. So x is k, right? So put x as k. Y minus k is equal to 0. So y is equals to k. So therefore what I can say? Therefore the point B is going to be x is k and y is also k. So we got equation as k comma k, right? Okay, next B is done. Okay, now let us go to the third point, which is C, correct? So the third point is formed by the equations. Okay, you can check it. It is equation 3 and equation 2, correct? 3 and 2 intersects at C. So if I solve that, here same thing I'll take. Okay, so from the equation 3, I'm going to take x is equals to k from 3, because already we know, right, x minus k is 0, so x is equal to k. So therefore what I can write with the 2, that's equation 2 was x plus y is equal to 0, so I'm taking x as k plus y is equal to 0, so y is equal to minus k. So therefore what happens here we can take it as y as k. So therefore point C is going to be k comma minus k. Okay, so now we got all the 3 points. So let me write those points over here, and the coordinates of B is going to be k comma k, coordinates of C is going to be k comma minus k. So we got coordinates of all the 3 points. So now we can use area of a triangle formula. So area of a triangle is given by 1 by 2 into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, and close the modulus. Now go for substitution. Okay, if you're going to substitution for that, half into modulus of, so we have to name it x1 y1 x2 y2, right? So let us take this as x1 comma y1, okay, this as x2 comma y2, this as x3 comma y3. Okay, you can take in any order, it is not going to affect. Okay, it will be the same. So let's substitute. X1 is 0, right? 0 and anything is 0 only. So if you want, you substitute, or you can write 0 directly. Okay, so but still I will write it. So y2 is what? Y2 is k, and y3 is minus k. So it becomes k plus k, plus x2 is going to be k into what is y3? Y3 is minus k, and y1 is 0, minus 0, plus what is x3? X3 is again k into y1. So y1 is 0, correct, minus y2 is k. So modulus. So continue with this. Half into 0 into anything is 0, right? So we'll put it 0, plus now you see k into minus k. So it will be minus k square, correct? Now again over here, k into 0 is k, and k into minus k square. This also will be plus minus k square I will get. So half as it is in modulus, minus k square plus minus k square will give you minus 2k square in the bracket, right? So as you all know that modulus means we can remove the negative sign, correct? So which gives you what? 1 by 2 into 2k square. So cancel 2 and 2, the answer will be k square. So what's the final answer? The final answer is area of triangle ABC is equals to, we can say, k square. Okay, this much of square units. Okay, that's it. It is question number 7. So now let's move on to the question number 8. Okay, what does question number 8 says is, find the value of p so that the three lines 3x plus y minus 2 is equal to 0, px plus 2y minus 3 is equal to 0, and 2x minus y minus 3 is equal to 0 may intersect at one point. Okay, so even though they have told it as may, so we will take it as they intersect at one point. So there are three different lines, correct? Let us take those three lines as like this. Okay, they are intersecting at point P. Okay, so according to the question, okay, let us take this equation as per given 3x plus y, 3x plus y minus 2 is equal to 0, and this equation as px plus 2y minus 3 is equal to 0, and this equation as 2x minus y minus 3 equal to 0. Okay, so according to the question, they may intersect at one point, correct? So that means what? The solution of this point is going to be the solution of all the three lines, right? So the coordinates of this point is going to be the solution of all the three lines. So therefore, if you closely observe, 3x plus y is equal to minus 2, and 2x minus 3 minus y minus 3 is equal to 0. They don't have the p, correct? So they are pure equations. So without the third unknown variable, that is p. So what we will do, we will solve these two equations. Okay, so let me take this equation as equation 1, this as 2, and this as 3. So we are going to solve equation 1 and equation 2. Okay, now what's the benefit here? If I solve these two equations, I'll get x and y value, and x and y are the coordinates of that point where the lines 1 and lines 2 will meet, correct? So okay, so therefore what we can do, let us solve this equation. Okay, so which will be 3x plus y, let me take 2 other side, so I'll be getting 2. Okay, now here it is 2x minus y is equal to 3. You understood what I have done, right? So I shifted this minus 3 other side, I got plus 3, minus 2 other side, I got plus 2. Now go for elimination. Okay, so y and y we can cancel. 3 plus 2, 5. 5x is equal to 3 plus 2, 5. So x is equals to 1 I will get, correct? Now let me find one of the values. Okay, let me find the value of y. So for that I will take, okay, equation 1 is 3x plus y is equal to 2. So x is 1. So I'll put 3 into 1 plus y is equal to 2. So y is equal to 2 minus 3. Y is equal to minus 1. So I got x and y. That means I got the coordinates of point P. So point P, x comma y is what? It is 1 comma minus 1. Okay. So now already we know that is only one point of intersection for all the three lines, correct? Now this is must that the px comma y should be the coordinates of the third equation, that is px plus 2y minus 3. So what we can do here, since p is a solution of equation 3. What's equation 3? P of x plus 2y, sorry, not p of x, okay, px, okay, 2y minus 3 is equal to 0. That means we are going to take x comma y as 1 comma minus 1. Since it is a point on this line, okay, point of this line, it's going to be the solution. So that will be p into 1 plus 2 into minus 1 minus 3 equal to 0. So if I simplify, p 2 into minus 1 is minus 2 minus 3 is equal to 0. P minus 5 is equal to 0. So p is equal to 5. So that's an answer. Okay. Move to the question number 9. So what does it say? If three lines whose equations are y is equal to m1x plus c1, y is equal to m2x plus c2, and y is equal to m3x plus c3 are concurrent, then show that m1 into c2 minus c3, m2 into c2 minus c1, m2 into c3 minus c1, and m3 into c1 minus c2 is equal to 0. So in the question number 9, the first word what they had used is concurrent, right? CONCURRENT. Okay, concurrent means what? The three lines, they intersect at one point. Okay, and since they meet at one single point P, we call that point as concurrent point, and the lines are called as concurrent lines. Okay, so each of these lines are given with the different equation. So the equation of the first line, let us take it as this as equation number 3. So since they meet at one point, so if I find the coordinates of x comma y, that will be the concurrent point, correct? So I need to find that. So for that, what we'll do, we will solve equation. Okay, you can solve any equation. You can solve 1 or 2, 1 or 2, 2 or 3, or 3 and 1, any pair of equations you can solve. So what we will do, we will solve equation number 2 and 3. So both are equal to the same y, right? They're equal to y. That means what I can say, equation 1 is equal to equation 2 I can take, because both are equal to y, right? So even if I subtract, it becomes the same thing. So if I take in that way, I can write this as m2x plus c2 is equal to m3x plus c3. So all the x's one side and all the c's other side. Okay, if I arrange in that way, so here I can take x common. That will give me m2 minus m3 is equal to c3 minus c2. So therefore, what is x? It is c3 minus c2 divided by m2 minus m3. So here we got coordinates of the x, correct? So now with the help of this, we will find the coordinates of y. Okay, so to find coordinates of y, you can go with equation 1, or even you can go with equation number 2. Equation 3 or equation 2. So let us take equation 2. Okay, so I am going to take a help of equation 2. So what is equation 2? It is y is equals to m2 x plus c2, correct? So we are going to replace x as m2 into, see, this becomes c3 minus c2 by M2 minus M3 plus C2. Okay, so let us further simplification. If you open the bracket, it becomes M2C3 minus M2C2 plus. So if you take an LCM, this should be multiplied here, right? It will be C2 into M2 minus M3. So whole divided by M2 minus M3. So now we'll just open the bracket here. So this, let me keep it as it is, M2 C3 minus M2 C2. If I open bracket here, it becomes what? C2 into M2. So plus M2 into C2 and C2 into M3. It becomes M3 C2. So whole divided by M2 minus M3. Okay. Now you can see minus M2 C2 plus M2 C2 gets cancelled. So what is left? So y is equal to M2 C3 minus M3 C2 divided by M2 minus M3. So this is the coordinates that we got. So this is coordinates of point P. So next what we need to find? We need to find the relation. What is the relation? So they want us to prove something, right? What they want us to prove? To prove this, what we are going to do is we'll substitute x and y in equation 1 because we had used equation 2 and equation 3, right? Equation 1 we haven't used. So what we'll do, we'll substitute equation 1. Okay, so let us substitute, that is the equation 1, right? So equation 1 is y is equal to m1 x plus c1, correct? What we'll do, let's keep it for time being this one. So let me solve the left hand side. So this will be m2 c3 minus m3 c2 divided by m2 minus m3. So here what happens, I can cancel these two, correct? When I cross multiply, they'll get cancelled actually. So let me cancel now only. So now this is solved. So in the numerator left over is, so now basically what I need to prove, if you see here, m1 c2 minus c3, m2 c3 minus c1, m3 c1 minus c2. So basically I need to group all the m1s together, m2s together, m3s together. Okay, if I do that, I'll get the answer. It's simple only. So you identify here how many m2s I have. You can check in this. See, here one m2, here one m2, correct? Then here one m3 and here one m3. Then here one m1 and here one m1. So if you look into this, what I need to get, m1 into c2 minus c3, correct? So here if I take m1 common, it is c3 minus c2, but I want c2 minus c3. That means basically what I need to do, I need to take everything to the other side, right? So even though you can do it later, but now if you look into it here, so it's very clear, correct? So I need to shift all of them to the other side. So let us do that. Okay, so if you go for a common factor, see here, if I getting m1 common, so it becomes c2 minus c3. If I take m2 common, it becomes c3 minus c1. If I take m3 common, it becomes c1 minus c2, which is equal to 0. Hence proved. Okay, so let's move on to the next question. Okay, let us work on the 10th question. The 10th question is, find the equation of the lines through the point 3 comma 2 which makes an angle 45 degree with the line x minus 2y plus 3. So in the question number 10, if you observe, what they want to say is there is one point P. Okay, the point P is 3 comma 2. So through this point there are two lines passing in this way. Okay, and this line makes an angle. Which two lines? These two lines, okay? Makes an angle 45 degree with the another line. So that line equation they gave. What is the line equation of the line? That is x minus 2y is equal to 3. This is x minus 2y is equal to 3. Okay, this is what is given. Okay, so now you can see here two lines, right? Both are making 45 degree angle. Okay, let us consider this line. Okay, we will take this line, okay, and this line. So we can find the slope of both by with the help of these two. Okay, just for an example, we'll take these two lines. So angle made over here is how much? 45 degrees. So let us mark theta as 45 degree. Okay, now if I take this line, see in these two lines, to find the equation of the line, I know the angle. I need to find slope of this line, correct? Point already we know, slope only we need. So for that, slope of this line we can find. So x minus 2y is equal to 3. Let me take the slope of this line. So m1 is equals to what I will get? Minus a by b, correct? Here what is a? It is 1. What is b? It is minus 2. So therefore what I will get? 1 by 2. Okay, then what about m2? So let m2 be the slope of the line L2 or L1 we can take. Okay, let us take it as L1. So therefore I can write m2 is equals to m. Okay, once after writing this, we can go with the slope formula. So what is the slope formula? So slope is given by, okay, tan theta, correct? Tan theta is equal to, just recall the formula. The formula is m1 minus m2 divided by 1 plus m1 m2, correct? So what we will do, m1 is 1 by 2, m2 is m, right? We can interchange, that's not a problem. So we'll interchange this a little bit to make it a little simpler. Okay, so let us use, don't interchange, let us use as it is. Okay, so tan theta, so tan theta is 45, right? It becomes tan 45 degree equals to modulus of m1 is 1 by 2, let us take it as 1 by 2, minus m2 we will take it as divided by 1 plus m1 is 1 by 2, correct? So 1 by 2 into m. If we solve it further, it becomes 1 minus 2m divided by 2. Okay, this is 2 plus m by 2 modulus. So you can cancel this 2 and 2. So tan 45 is 1. So therefore we can write, therefore 1 minus 2m divided by 2 plus m, which is equals to 1. Since there is a modulus, if you want to remove modulus, what happens? We are going to take 1 as plus or minus 1. So that means 1 minus 2m by 2 plus m is equal to plus or minus 1. That means there are two cases, correct? So the first case, okay? So we'll go with the first case. In the first case, we will take this as 1 minus 2m by 2 plus m is equal to plus 1. If you solve this, what do you get? 1 minus 2m equals to 2 plus m. If you simplify, so bring 2m this side and 2 other side, okay? So I'll be getting this as 1 minus 2 is equals to m plus 2m. That means this will give us m is equal to, so 1 minus 2 is minus 1. So this is 3. So it becomes minus 1 by 3. Okay. So now let us solve it. Okay. Now slope we got, correct? And point already we know. So putting this slope in the equation. Okay. Which equation? Slope point form. What is slope point form? Y minus y1 is equal to m into x minus x1. It is basically called as slope point form. Okay, so what is y1 and x1 and y1? So this is x1 and y1. Okay, so y minus 2 is equal to slope is 1 by 3 into x minus x1. x1 is 3. Okay, solve it further. It becomes 3y minus 6 is equals to, and here minus x plus 3. So simplify, rearrange standard form. If you rearrange in the standard form, it's going to be x plus 3y, and I'm bringing 3 the other side, becomes minus 6 minus 3 will give you minus 9, which is equal to 0. Okay, it is one of the equations. So now we need to find the next equation, correct? That's our case 2. In the case 2, what we will do? So we will take, in case 2, let us take this as 1 minus 2m by 2 plus m as minus 1. So minus 1 means what happens? It's 1 minus 2m is equal to minus 1 into this will give you minus 2 minus m. So if you simplify it further, so 2 goes this side, 2m you bring this side. So if you do the transposing, so 1 plus 2 is equal to minus m plus 2m. So that gives you 1 plus 2 is 3, m minus m to m will give you m. So m is equal to 3. Slope I got 3. So here I got slope as minus 1 by 3, correct? Now again we are going to put in the same form. Y minus 1 is equal to m into x minus x1, correct? So let's do that, okay? So when I am doing that, in this case, so here y minus y1 is 2 equals to m is 3 now, right? 3 into x minus x1. So x I keep as it is, x1 is 3. So open the bracket, y minus 2 is equal to 3x minus 9, correct? Now rearrange. So now 3x is positive here. I'll bring everything other side, okay? So I'll be getting 3x, then minus y, and then 2 comes this side, 9 plus 2, minus 9 plus 2 will give you minus 7 equal to 0. So this is our second equation. So these are the lines, okay? That's it. Question number 11, that is find the equation of the line passing through the point of intersection of the lines 4x plus 7y minus 3 is equal to 0 and 2x minus 3y plus 1 is equal to 0 that has equal intercept on the axis. Now let us mark this equation as 4x plus 7y is equal to 3 and this line as 2x minus 3y is equal to minus 1. So here I have transposed 3 to the other side and here 1 to the other side, okay? And these two lines intersect at point P, okay? The coordinates of this point P are P, x, comma, y. There is one line which passes through and it has an equal intercepts on the axis, that is x and y axis, okay? Now we need to find the equation of this line. So now we know that we can use point intercept form because we know the point and we know the relation between the intercept. So since I told you we know the point, means we are going to solve these two equations and get the point, okay? Let us mark this equation as equation 1 and this as equation 2. So we are going to solve equation 1 and equation 2 by elimination method, okay? So we got the solutions as x is equal to 2 by 26, which gives you 1 by 13, and y is equal to 5 by 13, okay? So now what we are going to do is, now we know that point we have got, we are going to use slope intercept form. So the slope intercept form is x by a plus y by b is equal to 1. So in the question it is told that equal intercept, correct? So equal intercept means A is equals to B. So therefore what happens to the equation? Equation becomes x plus y by A is equal to 1. That means x plus y is equal to A we will get, correct? Now what I will do, I know the value of x and y, so I'll substitute that, okay? X is 1 by 3, y is 5 by 3, sorry, 1 by 13 and y is 5 by 13. So let's substitute over here. We get 1 by 13 plus 5 by 13 is equal to A. So therefore A is equal to 6 by 13. So let us substitute this in the equation. So that is x plus y is equals to A. That means x plus y is equal to 6 by 13. Take that in the other side. So the equation becomes 13x plus 13y is equal to 6. So this is the required equation. So this is the equation of the line which passes through the point P, where these two lines intersect, and this line makes an equal intercept with the x and y axis. Okay, that is the solution for this.